All right, so essentially the data stream here writes primitive Java data types to the stream. That's very important to create binary files. A buffered output stream creates a buffer for the stream. So remember the importance of buffering. The buffering optimizes input and output operations and makes them much faster, because this is what the operating system is expecting for most programs to do with the files. You'll use buffering. All right, so this file output stream connects the stream to a file. So this is essentially just says, give me the file path and I'll give you a file object which you can use further along. Okay, so there are some constructors associated with these classes, and recall we just said that the file output stream object is associating whatever file you're trying to open with the actual file, and therefore this one right here will allow you to specify true or false whether you want to work with the output file in the append mode or just replacing it from the beginning. So if you're working with append mode, it will be just adding information at the tail of the file, and anytime you have to add more information to the file, append is your huge friend, because it's guaranteed to be atomic or transactional. Or, multi-user environments will benefit from appending mode easily, because this way everything is transactional, so no one is going to lose any data. So append, whenever you can use append mode, use it. It's your friend. Okay, so we should see example, and here it is, right? So if we wanted to create the data output stream object, we create it as an out object reference right here. So we constructed from the file output stream, which can take a string as a path to the to a specific location of our file, and then we most likely we want to have it buffered, and then we also use the data output stream constructor, which takes both of these objects, right? So I could take this like that and put it in my main sample right here. And of course it would be desirable to fix all the imports that we need, and there you go. I'll just accept the defaults, and so these are my input output, and this one is telling me unreported exception. Oh, of course, right? So we need to, if ever you need to even try opening a file by creating this data output stream, you have to say try, and you need to be able to catch the exceptions. So I need to say try and catch and specify the exceptions that I want to use. And on the previous slide, that was the reason why we listed possible exceptions. For instance, file not found exception is one that can be thrown by the constructor of the file output stream. Therefore, in my code, I'll try that. I'll just say file not found exception EX for now, and I essentially add another import right here, file not found exception, and so this way I can then make everything look nice right there. And so there you go, right? So this is an automatic formatting feature used directly in NetBeans, which made this series of new look like that. Okay, so I may agree or disagree with the white space formatting, but that's okay. I'll keep it for now. All right, so what else? This is obviously the appending mode for output, right? So if we want to append this stuff to the file, we just have to say true, and so this will be the appending mode. So what I usually do, I usually basically sometimes just say here append to remind myself that this true represent the append mode. Now it's kind of maybe unrealistic to have the books in some sort of current directory. So perhaps I can just look at the location of my project, right? So where's my project located? Somewhere here. You can see I can copy this. Okay, I can just press Control-C, copy this, and go to some kind of file manager here and specify this location right there, and then go create maybe a new folder that's called data, and under data I may store my file. So this is the real path. As always, if I wanted to specify the full path for whatever I'm doing here, I would say then paste this in, and of course I would instantly change those backslashes to forward slashes, because this is something I would use instead of backslashes, because they have to be duplicated. And once again, let's do source format, see how that comes out. Well, it's kind of like puts everything in just use different format. Puts everything back. I won't struggle with this. I'll just like bring it to make it visible on your screen. Okay. So moving on. So we can construct the stream, and let's see what we can do with this. So once it happens, what we can do is that we can essentially when we have the this is, by the way, another example of using the output stream directly for just output stream is actually not related to just files. The system output is actually derives from output stream, and so therefore if we can just construct the output reference, you can use system out to use output stream as an interface. And this is just an example to remind you that this output stream can be used as if you need to pass system out to some method, then you can use output stream for the type of method to use, because sometimes you want to pass the file as your output stream. Sometimes you can just pass in system out, which will be printing on the console. So I'm not going to spend much time with copying and pasting this example. Just moving on to maybe see these methods. So let's take a look at this. So my next step in this sample might be that I can say, all right, let's basically let's have, maybe I'm just thinking that I'll leave this try and catch alone, and right here I can just say system.error.print line, just tell them that file not found, right? So we can say file not found in case if we run into something like that, and say ex.print stack trace, which is helpful for debugging. But on the next line we can say try, right there, try and catch IO exception for the next set of operations. This is another import that we need for exceptions, for IO exception. We do that, and we say that when we have this output stream, what we can do is oh, I just happened to declare it in the scope, so I'll put it up as a reference just like that, and then I'll just say out equals this. Once again, source format. Probably don't need this much of an indentation on any of this. Source format like that. Okay, that looks better. Right, so now I can say out, and you can see that I can write different things. So I can write, for instance, I can write an integer as a byte, and I can, for instance, I can write 65 decimal, and it should be interpreted by as an ASCII code for ASCII. Okay. For character A, uppercase A, and this is that, right? Then I can say out dot, let's say Boolean, right? Boolean, and we can write true, and we can also try writing false there as well, right? We can say write false right there, true and false. What else we can try writing in there? We can try writing. Let's try writing a double, right? So double could be 3.14, right? Something like that, to that level of precision. Let's see how that looks like internally. So that should cover like 8 bytes. So this is my version of pi number. Okay, then out dot let's output, let's see, we can output a string, right? Print characters, okay, print characters, and we can print characters A, B, C, D, E, F, 6 characters right there. So let's give this a try, and then I think what we can do at the end, we can say out dot we can flush, but we can simply close, right? So if we we can probably do both. Basically flush the data, make sure it gets saved, and then close the file. There's nothing wrong with that. And here similar error messages should come out from this try, and we can say instead of file not found, this would be writing binary data failed. All right, so we can just say that and print what the stack trace will say in this situation. So this is an example of me trying to create a file. So let's see if I can compile this. Right, just if I compile this, I should be able to write all this information into a file. If I run this, it runs silently, doesn't say anything, which I'm assuming is a success in my case. And if I just copy and paste my path to the location of this supposedly a brand new file, right? So I just go again to this location right there, and it had created books bin. Obviously, the bin is one of the registered format on my system that associates itself with VLC media player, which is obviously nothing to do with that, so I'll ignore it. Instead, I'll try opening some kind of a binary editor. Right, so I can say file open file, right? Point myself to this location right here, right? Point myself to this location right there, and say bin, and then say open with, and pick binary editor right there. Okay. All right, so open like that, and so let's see what we get as a result. So this is my program, okay, with all of these writes, and we can then compare it with what information can be visible in the file.